Hello and welcome to this week's Feature of the Week, where we'll be talking about sparse data and PK analytics. Sparse data means that we have only one or very few observations per individual or occasion, so this means we cannot reliably estimate individual PK parameters. If you look at the dataset for the individual with ID 1, for example, we only have one observation at time point of 24 hours, so we're not going to be able to estimate any individual PK parameters. However, we can calculate mean profiles based on data pooled across individuals. We can still stratify this data. For example, here we have different dosage groups and studies so that we can analyze that separately. We can separate the data by any categorical covariate and calculate mean profiles for each group. So let's take a look at this data in PK analytics. I'll make a new project and browse to my data. Here I'll just tag the nominal time correctly as nominal time. The time column is time. The other columns are recognized automatically, and my dosage group I'll tag as a categorical covariate so that we can use that for stratifying, and click accept. Instead of going directly to tasks, let's look at plots, where I'll go ahead and turn off the error bars so we can see this more clearly. So here, if I highlight the data, you can see that for each individual, we only have one single data point, but I do have information through time if I pool all of my individuals together. So we're looking at this mean curve, and I can further stratify this by dose group and study. And if I go ahead and put the y-axis on a log scale, we can also get an idea for each dose group if the elimination phase looks like exponential decay or not. So let's go to tasks. At the top of the non-compartmental analysis section, there's a new setting in version 2024 to turn on and off sparse NCA. When I turn that on, I have two new options that appear, the sparse data stratification and the BLQ method. For the sparse data stratification, this is where I can select the categorical covariates to stratify my data. That is, for which groups I would like to estimate mean profiles. So here I'm going to stratify by dose group and study. And my other setting is the BLQ method, which comes with some additional options that give more flexibility for sparse data. There are three possible methods to handle BLQ samples for sparse NCA. The first is a single rule. In this case, I have the same options as I would doing a regular NCA, treating my BLQ samples as either missing, 0, using the LOQ value, or half the LOQ value for the calculation of mean concentration. But I may want to handle things differently for time points where there are a lot of BLQ samples compared to those with few or none. So to do this, I have additional options where I can use two rules, where I can define what is a lot of BLQ samples based on either the absolute number or the fraction of the total number of samples. For two rules based on the absolute number of BLQ samples, I first define a threshold for what is a lot of BLQ samples based on the absolute number per time point and stratification group. Then I can choose either to replace these BLQ samples when the threshold is exceeded or to replace the mean profile directly. Then I have a second rule for when there are only a few BLQ samples, that is, below my threshold, and I can specify a different option to replace those BLQ samples. Two rules based on the fraction of total number of samples is very similar, but in this case my threshold is a percentage of the total number of samples per time point and stratification group. And I define two rules for what to do when there are a lot of BLQ samples or only a few BLQ samples. This rule can be useful if the number of samples is quite different across time points or stratification groups. Finally, in all cases, I can also optionally verify that my mean samples stay above a global LOQ value that I can specify. In this case, I can replace the mean sample with one of the standard options defined separately before Tmax and after Tmax. Here, the LOQ refers to the global LOQ value defined above. So let's look at a concrete example. Here I have sparse data where I have BLQ measurements at 200 and I have different numbers of observations and BLQ measurements per time point. So I have to decide how to handle the BLQ measurements. First, I can choose to use a single rule to replace my BLQ samples. Here I'm replacing them by 0, and then all of the time points will be included in the calculation of the mean profile. Note that at the last time point, half the data points are BLQ, so we might have less confidence in that data point. So one option would be to use 2 rules based on the absolute number of samples. So here I'm specifying if 2 or more of my samples are BLQ for a particular time point, then I will consider my mean sample missing. So this gets rid of my mean sample at 168 hours, but this will also get rid of my mean sample at 24 hours, where I had 2 of 9 measurements below the limit of quantification. Then I replace the other BLQ samples with 0, and then the mean profiles are calculated without the 24 and 168 hour mean samples. I have another option to specify the threshold as a fraction of total samples, which can be useful when I have differing number of observations per time point, as is the case here. So I specify a threshold of 33%, and in this case, only my last time point, where 50% of the samples are BLQ, will have the mean sample missing, and not my earlier time points. Then again, I replace the other BLQ samples by 0, and the mean profiles are calculated, only omitting the 168-hour mean sample. So after selecting our stratification and BLQ settings, the other settings are just like a regular NCA. I can set a partial AOC, my acceptance criteria, and I can select different parameters. So my mean profiles are calculated in the background based on these settings, and I can see them on the Check Lambda Z tab, which will show which points are used in the mean profiles. There are a few additional parameters that are available for sparse data, and these are the standard errors of AOC all, AOC last, and the standard error of Cmax. So I can enable these parameters if I would like to calculate them. And note that the standard error for the AOC parameters is only available for linear integral methods for the calculation of AOC. Now I've picked all my settings. Now I'll just save my project and run the analysis. So let's look at the results. In the individual estimates tab of the results, I can find the estimated values of my parameters for each of my groups according to my stratification settings, which we can see here. So I have estimates per dose group and study. On the Summary tab, I can see the different statistics for my selected parameters, so the minimum or maximum or average across the different groups. I can also choose to stratify. So for example, I could stratify by dose group in order to see my parameter values combined across studies for each dose group. I can look at the table of concentrations organized according to my stratification with different metrics. The mean row is highlighted here in green, and it corresponds to the mean profiles used for the NCA. The mean values are calculated using the BLQ rules defined in the settings. The individual profiles are not displayed by default, but I can turn them on. And finally, I can see exactly which points in the mean profiles were included in my Lambda Z calculation. In the plots, I can also see the points included for the Lambda Z calculation and the Lambda Z regression line per mean profile in the individual fits plots. And I can also look at the data as it's interpreted for the NCA data with the stratification fixed to the one specified in the sparse NCA settings, but the other plots are unavailable in sparse data mode. So what are the details of calculating mean profiles? The concentration per unique time is averaged across subject occasions per stratification group, so the subject occasions are treated independently. Sparse NCA is also available for urine data, so note that for urine data, this would be the mean rate per unique midpoint. It's also important to point out that the mean profiles are calculated based on nominal time if available in the data, and otherwise based on the actual time. And finally, if dosing regimes differ across subject occasions that are in the same group, that of the first individual is kept, and the same is true for urine data. If there are different volumes across individuals in the same group, only the volume for the first individual is kept. For more information, you can take a look at the demo that's available for sparse NCA and our online documentation. Thank you for joining us and have a great week.